I'm Seth Grassoff, junior here at Texas A&M University.
Blaine is Edsney. I'm a sophomore at Texas A&M University.
Timothy Earth, senior, Texas A&M University.
Colin Weezy, senior, Texas A&M University. So the purpose of our project is to systematically process the overabundance of information on the Texas Railroad Commission GIS viewer and reformat that data in a configuration that's convenient and applicable to all users. The end product should include data already attainable, such as latitude and longitude, coordinate reference systems, and all corresponding permits and records. Currently, the Texas Railroad Commission website provides an interactive map used to record and locate any GIS data registered to the state. This website provides information for individual wells, pipelines, surveys, LPG, CNG, LNC, OCP, and alert areas. The information is presented on the map at each site represented by specified symbols on the map, each of which is described in the map legend. By navigating over these symbols, a text box reveals information pertinent to any user of the database. The Texas Railroad Commission GIS viewer provides hyperlink references to pictures of handwritten documents that include vital information applicable to each individual well site. These documents, provided by the state to oil companies, serve as the basis for record keeping on each oil site. The information on these documents provides data that isn't easily identifiable to users when accessing the map. If you notice on the screen, the cursor is highlighting hyperlinks to pertinent data included in most wells. We use the information at the bottom of the screen here to extract all of our data. This is an example of how to navigate to the handwritten documents provided on each well. It becomes a rigorous task having to navigate away from the GIS viewer website to this site, Nebulous. As you can see, if you're uneducated on the paperwork submitted for each well site, this process of deciphering information can become tedious and complex. You notice there's multiple pages of information, but no directory to really what is what. I click here to reveal a W3 form that isn't really filled out with any information, but submitted to remove this well from schedule. Later in the video, we will reveal a document similar to this, but with completed filings. Seth Grassoff will now continue the presentation.
As you can see, this information is dense with a lot of material that is constantly reciprocating the same data. These forms cover years of data with no systematic basis for update. In this document here, the data repeats itself over a course of 13 pages. This is a small example of the lack of complete forms of disregard for organizational standards. Some file documents can exceed 250 pages, making data acquisition nearly impossible. As we navigate back to the GIS viewer, you can see when we select another well location, the hyperlinks are absent or not up to date, revealing inconsistent data input by all the oil companies. Now what we have here is a completed W3 form, which identifies cementing to plug abandoned data and casing and tubing record after plugging. We extracted our data from completed documents similar to this. When processed on an Excel-style spreadsheet, the usefulness associated with the refinement of the system and the increased user accessibility with the aggregation of this processed data becomes relevant. Here is a first view of our completed project in an Excel spreadsheet. Blaine Edsney will continue with the description of this table to you.
Each team member was tasked with an equivalent amount of data accumulation. A basis for fundamental information to include on each well was established to delineate the task each member was responsible for. An equivalent number of oil wells were tasked to each team member to provide an efficient and fair workload. Data from RRC GIS viewer was recorded and transferred into Excel spreadsheets by each partner. In total, 30 well locations with associated API number and applicable data were replicated in an Excel file. 19 different attributes of each well location were recorded. The first attribute you see here is the associated API number, which are color coordinated to represent wellbore status. The red indicates a plugged wellbore. The black indicates a canceled wellbore. The brown indicates a dry hole. The green indicates open and currently extracting wells, and the blue indicates permitted location. As we zoom out to reveal more data, you can see the different traits accounted for each well drilling procedure. Timothy Ernst will give you more knowledge of this data and how it applies in real-world applications.
As you can see here, we provide basic information that one would see at first glance, such as latitude and longitude, operator and lease name, county, and type of drilling procedure. As you move across the screen, we begin to provide more in-depth information pertaining to drilling and plugging procedures, such as casing size and depth, to cementing, fluid and chemical, and downhole pluggings. This information is required by oilfield drilling companies to maintain proper downhole drilling operations and sustain wellbore longevity for successful resource extraction, as well as future well usage after wellbore plugging. By providing an organized datum from well coordinates and drilling depths to cataloged inventories of all downhole fluids and chemicals, future operations can be conducted by drilling companies in the localized area will begin to have a clear understanding of the necessary equipment and resources needed for efficient drilling and extraction procedures. Data from pre-existing well sites will give insight to the area of operations by showing all recorded information of resources and materials used at these sites that lead to either successful extraction or abandonment of wellbores, which then can be used to provide stronger accuracy in the future drilling. Along with fluids and chemical count, casing size, and formation point data provided can be used for the geological factor of drilling operations by showing the crust composition the bores drilled through, as well as the shift in casing size to compensate for excess pressure on the wellbore.
After review and completion, an anonymous individual, unrelated and unaware to the pending experiment, was asked to navigate the Texas Railroad Commission map for well information. Following the test, the individual was then asked to navigate the refined version provided by this experiment to see if the data assessment process was less confusing and more straightforward. It was mutually agreed that a successful result would provide a scenario in which the individual was unable to ascertain the desired information on the RRC GIS viewer, and also successfully obtain said information on the refined Excel spreadsheet created by this experiment. The experiment resulted in a successful trial as the test subject was unable to get even remotely close to the target data on the RRC GIS viewer, and then successfully navigated the designed Excel sheet to obtain target data. Therefore, this preliminary study supports our hypothesis by achieving greater accessibility in a formatted datum on Excel. Thank you.